There is a question that has followed humanity for thousands of years, drifting quietly across the galaxies like a whisper from the universe. If the universe is expanding, what is it expanding into? In the stillness of night, when starlight falls softly into the dark velvet of space, that question feels as intimate as a breath. It offers us a promise, a journey into the very fabric that holds every star, every memory, and every mystery science has yet to name. In this video, you will drift into a place where curiosity becomes gentle, where science bows before wonder, where space feels alive, breathing, expanding, embracing itself like a quiet cosmic being. If these moments touch your curiosity, please softly tap like and subscribe, so we may continue floating together through the endless unknown. And now, we begin with one simple yet profound question. What exactly is space? Space has always been something that makes us pause for a moment, take a breath, and look up at the sky as if waiting for an answer to fall softly from the stars. For centuries, we called the darkness between the stars a void, a place where nothing exists, no light, no matter. But the deeper we enter modern science, especially when we explore questions like universe expansion or expanding universe explained, we begin to realize that this idea of emptiness is merely an illusion of our senses. What is space? This question sounds simple, yet each time it is asked, it touches deeper layers of human understanding, like an echo in a cosmic cave whose bottom we have never reached. When Einstein introduced general relativity, he changed everything, breaking the view of space as a static stage and turning it into the main character of the universe's story. His words still resonate today. Space and time are not independent. They are two aspects of the same reality. That sentence opened a new doorway, a doorway leading into space-time expansion, where space is not a background but a flowing river, the breath of the universe itself. When we look at universe expansion, the essence of expansion does not come from galaxies rushing outward, but from the very fabric they rest on. Space is a physical field, structured, energetic, shaped by forces, and constantly evolving through delicate laws we are only beginning to understand. What our eyes see as empty darkness, science sees as an ocean of quantum fields, where virtual particles flicker in and out of existence like invisible fireflies. The great physicist John Wheeler once said, "There is no such thing as empty space. Empty space is the most active arena of all," and his words remain profoundly true at the quantum scale. Imagine standing inside a night that appears still, but beneath that stillness lies a quiet trembling, a breath, a vibration too subtle for human sensation. Space behaves exactly like that. A vast, unseen ocean filled with ripples of endless motion. And from that ocean, the question why the universe is expanding takes on a deeper meaning. If space is dynamic, if it can stretch, bend, tighten, or swell, then the expansion of the universe is no longer strange. It becomes natural, like a living organism growing with time. This is where dark energy explained enters the story. Dark energy is not a simple force pushing galaxies apart. It is a property of space itself. The more space exists, the more dark energy appears. And the more dark energy appears, the faster space expands. Like a melody that amplifies itself, the more it resonates, the wider it spreads. Physicist Sean Carroll once wrote, "Dark energy does not push galaxies outward. Space between them expands because it has a natural tendency to grow." And once we understand this, the idea of universe expansion becomes crystal clear. Space is not a place. It is a process. It does not exist as a static thing, but as an unfolding action. Space is a verb. Viewed through this lens, we see that the smallest quantum fluctuations can lead to the grand expansion of the entire cosmos. This brings a personal lesson I have carried with me for years. That sometimes the smallest, most delicate changes can lead to the greatest transformations. Space evolves through invisible trembling, and humans do as well, shaped by our quietest thoughts, by a new way of seeing, or by a question profound enough to awaken our mind. When we ask, "What is space?" we are not only studying the architecture of the universe, we are studying the architecture of our own perception. We discover that space is not distant from us. It exists within every atom of our bodies. We are part of space-time, and space-time is part of us. There is something humbling in studying expanding universe explained. Something that softens the heart as much as it sharpens the intellect. When we realize that ancient light from the dawn of time is still traveling toward our eyes, that vacuum energy is still shaping the curvature of the cosmos, we understand that we are only a single breath in the long rhythm of the universe. Yet it is precisely this smallness that makes us special, because we can question, we can understand, we can feel wonder about something infinitely larger than ourselves. In this expanding space, where boundaries dissolve, where time stretches, where everything drifts gently outward, we find something precious. The connection between human consciousness and the heartbeat of the cosmos. Space expands outward, but it also expands within us. And perhaps the greatest lesson carried by universe expansion is this: expansion is not merely a physical phenomenon. It is a state of being. We expand when we learn, when we listen, when we dare to look into the darkness and see the faint spark rising within. So when we ask, "What exactly is space?" we are also asking, "What exactly are we?" Space is vast, but the human mind is just as vast. Space keeps growing, and our spirits may grow with it. When we say the universe is expanding, our minds often jump to an image that is both dramatic and misleading. A grand explosion flinging galaxies outward like glowing fragments scattered into an infinite night. But this image, though poetic, is not the truth that modern cosmology reveals to us. To understand universe expansion, we must first unlearn the instinctive idea that galaxies are racing into a ready-made emptiness, a kind of vast, dark container waiting to be filled. The truth is gentler, stranger, and more beautiful than that. galaxies are not moving into anything. They are being carried by the growth of the very fabric that holds them. This is the heart of expanding universe explained. Space itself is stretching, creating more space between all things, even between galaxies that are not moving through space at all. They stand still in their local cosmic neighborhoods, yet the distance between them grows because space itself is swelling like rising dough carrying raisins farther apart. Stephen Hawking once said, "It is not galaxies flying apart, but space itself growing bigger in every direction." His words echo like a quiet correction to our intuition. This is not motion. It is becoming. To grasp this, we must ask again the ancient question, what is space? And we must ask it with the humility of someone looking at the ocean for the first time. Space is not a void, not a stage, not a silent box waiting for actors. Space is a field, a living fabric, a trembling grid of geometry and quantum potential. And as long as that fabric exists, it can stretch, it can twist, it can expand. This is space-time expansion, the quiet engine behind every galaxy drifting away from every other galaxy. Many people ask why the universe is expanding, but perhaps a deeper question is why space should do anything at all. Why should nothingness have properties? Why should emptiness be active rather than passive? Here, the universe surprises us again. Quantum field theory tells us that space is never empty, that everywhere, at all times, virtual particles appear and vanish, creating a restless sea beneath reality. Richard Feynman once remarked, "The vacuum is not empty, it is full of energy." He meant that even silence hums. And if space is full of energy, then it has the power to shape itself, to stretch itself, to become more than it was before. Here, dark energy enters the story like a ghostly conductor guiding an unseen orchestra. Dark energy explained is slippery, mysterious, but its effect is unmistakable. Wherever space exists, dark energy exists with it, and the more space is created, the more dark energy there is. The more dark energy there is, the faster space expands. A self-driving expansion, a cosmic engine that accelerates its own unfolding. To me, this is one of the most profound ideas in modern science. The universe is not expanding because something pushed it, but because space itself holds within it a quiet tendency to grow. As Alan Guth, the father of inflation theory, once said, "Space is capable of stretching itself at any speed, even faster than light." His work showed that the early universe expanded so quickly, it left everything we know far beyond its infant horizon. This is the subtlety many people miss when exploring expanding universe explained. The speed limit of light applies to objects moving through space, not to space itself. Space is free, unbound, not subject to the rules that govern matter. Space can outrun light because space is not running. It is unfolding. And this unfolding happens everywhere at once, with no center. When we look out from the Milky Way, we see all galaxies drifting away. and we might imagine that we are at the center of the cosmos. But astronomers in Andromeda would say the same, and observers in distant galaxy clusters would echo that observation. There is no center because expansion has no anchor. Space does not expand outward from a location. It expands within itself. This is perhaps the most elegant answer to the question, what is the universe expanding into? It is not expanding into anything, because there is no outside to expand into. Space grows by creating more space. The way a story grows by adding more sentences. No wall, no boundary, no outer container. Just the self-generation of geometry, happening everywhere with equal grace. When I first understood this, I felt a deep shift inside. The universe was no longer a thing expanding, but a process unfolding, a becoming rather than a being. And this becoming carries a quiet lesson for us as human beings. We often look for boundaries, limits, edges to define our growth. But the universe teaches us something else. That expansion does not require a direction or a destination. It simply requires the willingness to continue unfolding. The universe expands because space has the capacity to grow. And perhaps we expand because the mind has the same capacity. In the gentle silence of cosmic history, we discover that motion is not necessary for distance to grow. Sometimes, all that needs to change is the fabric beneath us. And as space-time stretches, it carries with it galaxies, stars, light, and every dream we have ever projected onto the night sky. Nothing is thrown outward. Everything is carried. This is the poetry of universe expansion. Not violence, but unfolding. Not explosion, but emergence. Even the raisin bread analogy, simple as it is, carries a quiet elegance. The dough does not push the raisins. It lifts them apart, giving each one more room to exist. In that sense, space too grants us room to exist. And this, to me, is the deepest emotional truth hidden behind the mathematics. We are living in a universe that is constantly making more room, not just for galaxies, but for possibility itself. There is no final horizon to this unfolding, no outer shell waiting to be touched. The universe expands because it can, and the mind expands because it wonders. Every question we ask stretches our understanding, the same way every moment of cosmic time stretches space. And so, when we ask what is the universe expanding into, perhaps the most profound answer is this: it is expanding into its own potential. And so are we. When we ask whether space is merely empty, whether the darkness between stars is simply nothingness, we are stepping into one of the most surprising truths of modern physics. For much of human history, the void was imagined as stillness, as a great and silent canvas stretching endlessly with no movement, no force, no breath. But the deeper we look, the more this idea dissolves like mist touched by morning light. Space is not empty, and the vacuum is not quiet. At the quantum level, what we call emptiness is a storm of activity, a restless sea of fluctuating energy. Even when there are no particles in sight, no atoms, no photons, the vacuum still boils with invisible motion. This is vacuum energy, the trembling foundation of reality. It is here, in this unseen shimmer, that space reveals itself not as a background, but as a living fabric. And in this realization lies one of the profound keys to universe expansion. Quantum fields do not rest. They quiver with zero-point energy. Energy that never disappears. Particles and antiparticles appear, annihilate, and reappear again in an eternal dance that is older than the stars. The vacuum breathes, and with each breath, space may change. Werner Heisenberg once said, "What we observe is not nature itself, but nature exposed to our method of questioning." And nowhere is this more true than in the vacuum. Our questions reveal that emptiness is not empty. That space is not silent. The vacuum is the quiet hum of the universe, a cosmic whisper that shapes galaxies and bends time. This restless quantum activity contributes to the pressure of space-time, and may even be tied to the mysterious force we call dark energy. Dark energy, the driver of the accelerating universe expansion, may be nothing more than the energy of the vacuum itself. That thought, quiet yet staggering, opens a new doorway into understanding why the universe is expanding. If space at the smallest scale, the scale of quantum vibrations, is constantly creating energy, then the large-scale expansion of the universe becomes a natural consequence. The smallest motions, almost impossibly tiny, rising to shape the largest motions imaginable. It is as if the universe grows because the vacuum refuses to sleep. Nobel laureate Frank Wilczek wrote, "The vacuum is not the absence of things, but the presence of all possibilities." And in that sentence is an entire cosmology. Vacuum energy is possibility in motion, the raw potential from which space continually unfolds. When you stare into the night sky while contemplating expanding universe explained, you are not looking into emptiness. You are looking into a field of infinite fluctuations that quietly sculpt the universe's destiny. And this realization changes how we see everything. The darkness between galaxies, once thought to be the purest form of nothing, is now understood as the most active arena in existence. Quantum foam ripples, fields shift, energy pulses at unimaginable scales. It is the silence behind the stars that carries the music of the cosmos. To me, this is one of the most beautiful truths in physics. That the void is creative, not destructive. That its quietness is not death, but a womb. The vacuum is the birthplace of everything we know. And this leads to a gentle but powerful lesson. Great changes often begin where nothing seems to be happening. The moments of stillness in our lives, the spaces we overlook, the pauses we try to rush past, may contain the seeds of transformation. Just as the vacuum births particles, choices, realities. In the same way, our quietest thoughts, our smallest shifts in awareness, can create vast expansions within us. And so the question, is space truly empty, is not just a scientific question, but a philosophical one. Because in learning that emptiness is full, we learn that even the places in ourselves that feel empty are full of hidden motion, full of potential. The vacuum teaches us that stillness is not stagnation, it is the beginning of creation. It teaches us that everything, no matter how quiet, is part of a greater unfolding. It teaches us that the smallest vibrations shape the largest destinies. And it teaches us that universe expansion is not a vast external drama, but a reflection of the way the universe grows from within its own silence. This is why I find vacuum energy so moving. It reminds us that the universe is alive at every scale, from galaxies spanning millions of light years to the flickering nothingness between atoms. It reminds us that reality is layered, textured, more intricate than our senses could ever reveal. It reminds us that complexity grows from simplicity, that light grows from darkness, that expansion grows from stillness. And perhaps most beautifully, it reminds us that we are made of the same shimmering vacuum that fills the cosmos. We are not separate from the universe's quiet unfolding. We are woven from it. Our thoughts, our breath, our consciousness are rooted in the same space-time that expands across billions of light years. We are the universe thinking about itself. And when we contemplate the vacuum, we are contemplating our own origin story. So perhaps the next time you look at the night sky, you will remember that the darkness between the stars is not emptiness, but the trembling heart of creation. That space does not rest, and neither do we. That the universe expands because the vacuum is alive, and we expand because awareness is alive. This is the poetry of modern cosmology. This is the truth hidden beneath silence. This is the quiet power of what we once called empty space. To understand why space bends, we must first understand that the universe is not built from the rigid geometry we once imagined. For centuries, humanity believed space was a flat, unchanging stage, a featureless backdrop where matter simply moved and forces acted. But Einstein looked deeper, and in the gentle stillness of his imagination, he saw something different. He saw that space is supple, flexible, responsive, almost like a living skin stretched across the cosmos. He saw that what we call gravity is not a pull, but a path. Matter does not tug, it shapes. Energy does not drag, it curves. And everything in the universe, from planets to photons, simply follows the curves laid beneath it. In this way, gravity is not a force, but the geometry of existence. John Archibald Wheeler famously said, "Space tells matter how to move. Matter tells space how to curve." It is perhaps the most poetic equation ever spoken. And it is here, in this exquisite reciprocity, that we find the foundation of universe expansion itself. Space bends because it listens. It responds. It adapts to the presence of mass and the hum of energy. Imagine a vast sheet of silk floating in a dark, quiet room, and imagine placing a single pearl at its center. The silk dips, not because the pearl is heavy, but because the silk is sensitive. Space is that silk. The pearl is every star, every particle, even you. But Einstein did not stop at curvature. He realized something deeper, something breathtaking. Not only can space curve, it can stretch. It can compress. It can ripple like water under wind. This idea would later become essential to understanding how gravitational waves move through the cosmos, and why universe expansion continues as a natural unfolding of space-time. In a sense, the universe expands because space is elastic, and elasticity is part of its nature. To ask, why does space bend, is to ask, why does a river flow, or why does a flame dance? These are not imposed behaviors. They are expressions of what these things are. Space bends because bending is part of its identity. This is where the quiet magic of relativity appears. Newton imagined gravity as an invisible rope connecting every object, a pull acting instantly across space. Einstein saw something more subtle, more tender. He saw that space-time takes the shape of whatever it contains, the way water takes the shape of a vessel. He saw that a beam of light, which knows nothing but straight lines, will still curve if the space it travels through has curved ahead of it. It is not the light that bends. It is the path. This gentle curvature connects the smallest quantum trembling of vacuum fields with the grand cosmic arcs of galaxy clusters, tying the microcosm to the macrocosm in one continuous narrative. Albert Einstein once wrote, "Curved space and curved time are not fiction. They are the fabric in which the universe is woven, and those words remain true every time a star is born, every time a black hole breathes, every time a gravitational wave ripples across millions of light years to reach us." But why should curvature matter for universe expansion? Because when the geometry of space changes, the universe changes. Expansion is not motion. It is geometry evolving. When space-time bends, compresses, relaxes, or stretches, distances change even if nothing moves. In this sense, expansion is the universe's response to its own internal shape. Mass and energy sculpt space, and space grows accordingly. This leads to one of the most striking realizations in physics: that the universe expands not because of a force pushing it, not because of momentum left from the Big Bang, but because space-time has a built-in ability to reshape itself. A universe that can bend can also stretch. A universe that can curve can also grow. This is why universe expansion is not an event, but a behavior. And the deeper we look, the more connected curvature becomes to the invisible engine of dark energy. Dark energy applies a kind of negative pressure, as if space is gently exhaling, creating more of itself in the process. This tendency amplifies the natural elasticity of space-time, allowing expansion to accelerate. Curvature and expansion are therefore not separate phenomena, but two verses in the same cosmic poem. As space-time curves around matter, it also expands where matter is absent. As galaxies sculpt valleys in the geometry, cosmic voids stretch outward. The universe breathes, inhaling curvature, exhaling expansion. Stephen Hawking once expressed this beautifully. Space is not flat, and the universe is not still. Everything is in motion because space-time itself is alive, and in this aliveness, curvature becomes a kind of cosmic heartbeat. To me, there is something deeply moving about this. That the shape of space determines the fate of everything within it. From the arc of a falling apple to the flight of a star across millions of light years. That geometry itself is destiny. When I first understood that space bends, that the universe curves itself into this beautiful, dynamic architecture, I felt something open within me. Space was no longer an empty stage, but a participant, a partner. And I learned something personal from this. That we too are shaped by the things we contain. Our thoughts, our wounds, our hopes, our memories. Just as matter shapes space, the contents of our inner world shape the path we walk. Curvature is not only cosmic, it is human. Space bends around every star, and our minds bend around every experience. The universe curves because it must, and we change because we must. Perhaps this is the softest lesson of all. That being flexible is not weakness, but the natural way of surviving in an expanding universe. That bending is not breaking, it is adapting. Space bends to allow galaxies to exist, and we bend to allow our lives to unfold. And in the gentle curvature of space-time, we see a reflection of the gentle resilience of the human spirit. This is why I believe Einstein's insight was not merely scientific, but profoundly spiritual. He showed us that the universe is not rigid, and neither are we. He showed us that everything can change, even the shape of reality itself. And he showed us that the key to understanding universe expansion is simply this: space is alive, and living things bend. Einstein changed our understanding of space and time in a way that feels less like a scientific correction and more like a quiet cosmic awakening. Before him, the universe was thought to be built upon a rigid stage, an empty container where planets drifted and stars burned, a vast immobile box against which motion could be measured. But Einstein looked into that box and realized the box was breathing, bending, stretching, alive in ways no one had ever imagined. He unified space and time into a single entity called space-time. A fabric so delicate and yet so powerful that it could ripple under the weight of a star, or tremble when touched by the smallest particle. A fabric that could expand and transform and evolve with the universe itself. This insight became the foundation of our modern understanding of universe expansion. Because in Einstein's view, it is not matter racing into emptiness, but space-time itself that swells like a rising tide. This idea was so revolutionary that even many scientists of his time resisted it. Yet over the decades, evidence layered upon evidence. and today space-time expansion is the backbone of cosmology. Einstein often wrote that space and time are modes in which we think, not conditions in which we live. But ironically, he proved that space and time are indeed conditions that shape our entire existence. He showed that time flows differently under gravity, that clocks beat slower near massive objects, and that space curves in response to energy itself. This curvature is not symbolic. It is literal. The planets orbit the Sun because they are following the curved pathways of space-time. And light bends around galaxies because space-time has folded ahead of it. Understanding space-time is understanding gravity, understanding motion, understanding the silent architecture of the cosmos. But perhaps the most poetic revelation comes when we realize that space-time does not simply curve, it changes over time. This is where modern physics steps into harmony with Einstein's vision. For if space-time is dynamic, then the universe cannot help but be dynamic. The expansion of the universe is not the aftermath of an explosion, but the natural evolution of a living geometric fabric, constantly rewriting its own structure. Carl Sagan once said, "Einstein showed us that the universe is not chaotic. It is patterned in a way that is deeper than intuition. This deeper pattern is the gentle elasticity of space-time, the very quality that makes universe expansion possible, even inevitable. If space-time can stretch, it will. If space-time can evolve, it must." The question is no longer, why does the universe expand, but rather, how could it possibly stay still? This realization struck me personally the first time I saw the equations of general relativity. They were not merely mathematics. They were architecture, the blueprint of a cosmic cathedral. And in those equations was a quiet truth: that nothing in the universe is rigid, not space, not time, not even the boundaries of what we believe possible. This flexibility of space-time leads naturally into the phenomenon of expansion, not as violence, but as unfolding, not as explosion, but as emergence. To me, this is one of the gentlest and most beautiful aspects of Einstein's legacy. He gave us a universe that is not static, not cold, but breathing. When he discovered that the equations predicted expansion, he resisted the idea at first, adding what he later called his greatest blunder: the cosmological constant. Ironically, that very constant is now associated with dark energy, the mysterious force accelerating universe expansion today. Stephen Hawking once wrote, "Einstein's greatest blunder may have been his greatest insight." For the cosmological constant captures the idea that space-time has an intrinsic ability to expand, even in the absence of matter. This insight forms a bridge between relativity and the modern mystery of dark energy, showing us that space-time carries within it a quiet pressure, a soft insistence to grow. To understand this is to see the universe not as a static container, but as a becoming, a blossom opening in cosmic slow motion. Einstein's vision is not only scientific, it is profoundly philosophical. He showed us that time is not universal, that simultaneity is an illusion, that past and future depend on where we stand and how we move. These revelations make space-time feel almost like a character in a story, changing, responding, sculpting the future through its own evolution. This gives me a sense of intimacy with the cosmos, as if we are not living inside a universe, but participating in it. And this leads me to a personal reflection, something I have carried since the first time I saw the bending of starlight during a solar eclipse. If space-time can bend, then certainty can bend. If the geometry of reality can transform, then so can the geometry of our inner world. This is the quiet lesson woven into Einstein's work, that change is not disorder, it is growth. That evolution is not chaos, it is refinement. The universe is expanding because space-time is capable of expansion, and we expand because the mind is capable of wonder. Brian Greene beautifully said, Einstein revealed that the fabric of the cosmos is as dynamic as the stories we tell about it. And this, to me, captures the heart of the matter. Space-time is not a passive ingredient. It is the main actor. Its stretching is universe expansion. Its rippling is gravity. Its bending is the dance of stars. And in that dance, we find a reflection of ourselves. For we too are shaped by our inner space-time, by the memories that curve us, by the hopes that stretch us, by the fears that compress us. Understanding that space-time can bend, stretch, and grow reminds us that our own evolution follows the same quiet laws. That flexibility is a form of strength. That expansion is a form of healing. That change is the most natural thing in the cosmos. Einstein changed our understanding of space and time. But more importantly, he changed our understanding of ourselves. He showed us that the universe is not static, and neither are we. And perhaps the greatest lesson buried inside general relativity is this: space-time expands because it is alive, and so do we. Dark energy entered the story of cosmology not with a roar but with a whisper, a quiet contradiction hidden in the faint glow of distant supernovae observed in 1998. Astronomers expected those ancient explosions to tell them the universe was slowing down, gradually relaxing after the tremendous push of the Big Bang. Instead, they found something astonishing, something that would forever reshape our understanding of universe expansion. The universe was not just expanding, it was expanding faster and faster. Galaxies were drifting away like lanterns carried by an invisible tide, and that tide was accelerating. The only explanation was that a mysterious form of energy was pushing space apart, a pressure woven into the fabric of space-time itself. This force was soon named dark energy, not because it is dark, but because it is unknown. It fills the universe with a silent insistence, shaping its destiny from beneath the surface of reality. Today, we know that dark energy makes up about 68% of everything that exists. More than matter, more than light, more than the galaxies that blaze across the night. As the physicist Michael Turner famously said, dark energy is the most profound mystery in all of science. And indeed, it is a mystery not of what we see, but of what holds the power to reshape cosmic fate. What makes dark energy so haunting is that it behaves like the opposite of gravity. While gravity pulls matter inward, dark energy pushes space outward, stretching the universe itself like a breath that never finishes exhaling. In Einstein's equations, this outward pressure appears as the cosmological constant, a term he once dismissed as a mistake. Yet with the discovery of accelerating expansion, that so-called mistake became the key to understanding the modern cosmos. Stephen Hawking once remarked, "The cosmological constant is not a blunder. It is the echo of a deeper truth." And with every passing decade, that deeper truth continues to unfold. Dark energy does not push galaxies like wind pushing ships. It stretches the space between them. And the galaxies simply drift with the current, not moving through space, but being carried by it. This is one of the most important insights of universe expansion. That expansion is not motion, but geometry changing over time. And dark energy is the quiet architect of that change. Imagine for a moment that you are floating in a vast ocean of nothing, yet the nothing is alive. It stretches beneath you, creating more of itself with every passing moment. This is the universe we inhabit, a universe where emptiness is not empty, but full of a negative pressure that drives the cosmos toward an ever-widening openness. As cosmologist Sean Carroll put it, dark energy is not a force pushing things apart. It is space expanding, because that is simply what space does. This statement captures the essence of the mystery. Dark energy is not added to the universe. It is the behavior of the universe itself. Yet, as compelling as this explanation is, it raises more questions than answers. Why does space expand? And why does it expand faster now than in the past? One theory suggests that dark energy is the energy of the vacuum, the same restless quantum froth that fills space-time with virtual particles popping in and out of existence. If the vacuum has energy, and if space continues to grow, then the total amount of vacuum energy grows with it. More space, more vacuum, more energy, more expansion. A cosmic feedback loop, delicate yet relentless. Another theory proposes that dark energy may shift over time, flowing like a slow tide across the universe. If this is true, then the ultimate fate of the cosmos remains uncertain. It may expand forever, growing colder and lonelier as galaxies drift beyond each other's horizons, leaving only silence. Or it may accelerate so dramatically that even atoms are torn apart in a scenario known as the Big Rip. Or, in an even stranger possibility, dark energy may weaken, allowing gravity to slow the expansion once more. Each path is possible, and none is guaranteed. But perhaps the greatest lesson is not in the destination, but in the revelation that the universe is still changing, still unfolding, still creating itself moment by moment. It reminds me that change is not something to fear, but something to understand. The accelerating expansion of the universe teaches us that stillness is an illusion, that beneath every calm surface lies a deeper movement. When I think of dark energy, I am struck by the idea that the greatest forces in existence are often invisible, imperceptible, yet overwhelmingly powerful. And I see the same truth reflected in our lives. The forces that shape us most are often quiet, subtle, internal. A shift in perspective, a moment of clarity, a breath taken in the right direction. Dark energy shows us that transformation begins in silence. That acceleration begins in stillness. As the astronomer Saul Perlmutter said when accepting the Nobel Prize, "The universe is teaching us that even the emptiest places are full of surprises." To me, that is the heart of the lesson. The emptiest parts of ourselves may carry the seeds of our greatest growth. And just as the universe expands because its nature is to unfold, we too expand when we honor the quiet energies within us. Dark energy may remain a mystery, but its message is clear. The universe is not finished, and neither are we. The idea that some galaxies seem to recede faster than light is one of the most delicate and misunderstood truths in modern cosmology. A truth that feels as if it should shatter Einstein's limits, yet somehow rests perfectly within them. And to understand this mystery, we first need to remember something essential about the universe. Nothing that moves through space can ever outrun light. But space itself is not bound by that rule. This is the heart of the confusion and the beauty. The speed of light is a limit on motion, not on expansion. When we talk about galaxies moving faster than light, we are not describing galaxies speeding through the cosmos like cosmic arrows. We are describing space stretching between us and them. It is the distance that grows, not the velocity of the galaxy. As astrophysicist Tamara Davis said, "Galaxies are not breaking the speed of light. They are simply being carried along by the expansion of space." Imagine two boats floating on a calm lake, anchored in place, perfectly still. Now imagine the lake itself begins to expand, its surface stretching like rising dough. The boats drift apart, not because they are moving, but because the water beneath them grows. The universe behaves the same way. Galaxies sitting calmly in their local cosmic neighborhoods are carried apart by the swelling of space-time. This is the essence of how galaxies can recede from us faster than light without violating relativity. Because relativity governs motion through space, not the expansion of the space itself. This also explains why so many galaxies are forever beyond our reach. Not because they outran light, but because the road they travel on is stretching faster than any runner can run. To me, this realization feels like a quiet shift in perspective. Like learning that the river's current matters more than the boat's paddling. That the background flow shapes our destiny more than our own motion. In the same way, the flow of space-time shapes the fate of every galaxy. As Nobel laureate Adam Rees beautifully said, "The problem, expansion of the universe is not a speed but a rate of stretching. This stretching happens everywhere, in every direction, to every patch of cosmic fabric. And the farther a galaxy is, the more stretching occurs between us and it, leading to the illusion of impossible speed. The light from distant galaxies struggles to reach us, fighting against the expansion of space. And sometimes, the expansion wins. The photons travel hundreds of millions of years, but the space between grows faster than they can close the gap. Such galaxies slip past the cosmic event horizon, drifting into a realm from which no light will ever reach us again. Stephen Hawking once described this poignantly. Some parts of the universe will never be visible to us, not because they moved away too fast, but because the universe grew too quickly. This thought fills me with a kind of cosmic melancholy, imagining galaxies filled with stars, planets, perhaps even civilizations, slipping silently over a boundary beyond which they will remain forever unseen. Yet it also fills me with awe that we live in a universe so vast, so dynamic, that its edges are not fixed but forever changing. This understanding also deepens our appreciation for what we can see. Every photon reaching our telescopes, every faint whisper of starlight, is a survivor. It has outrun expansion just enough to reach us, crossing a battlefield where distance itself was stretching apart. But there is another layer to this story, one that connects expansion directly to the nature of space-time. When Einstein showed that gravity is geometry, he also opened the door to understanding why universe expansion is not constrained like motion. Space-time can take any shape required by the energy within it, and one of those shapes is an accelerating stretch. Today, dark energy fuels this acceleration, giving rise to the cosmic inflation of distance. Dark energy does not act on galaxies. It acts on space. As cosmologist Katie Mack explained, dark energy expands the universe not by pushing things apart, but by pulling space open. This means galaxies are not escaping us. Space is unfolding between us. And there is a gentle tenderness in that idea. A reminder that the universe grows not through force, but through emergence. This perspective also shifts how I think about boundaries in life. We often assume distance grows because something is moving away. But sometimes distance grows because the world itself expands, and we simply drift with that change. Understanding this has brought me a sense of calm, a reminder that not everything we lose is because it ran from us. Sometimes it simply drifted beyond the horizon of our experience as life expanded around us. The universe teaches us that expansion is natural, that acceleration is sometimes silent, and that separation can occur without blame. But the universe also teaches resilience. For even as some galaxies drift away, countless others remain within reach, their light continuing to guide us through the darkness. It is in this interplay of near and far, reachable and unreachable, that I find one of the most profound lessons of cosmology. As physicist Brian Greene said, "The cosmos is not only stranger than we imagine, it is stranger than we can imagine." And nowhere is this strangeness more evident than in the gentle truth that galaxies can drift faster than light's ability to keep up. Not because they defy physics, but because space-time itself writes a different rulebook. If anything, this deepens my admiration for the structure of reality. That motion is limited, but expansion is not. That the universe knows constraints, yet also knows freedom. And the greatest lesson I take from this is that some distances grow no matter what we do. And that is not a failure, but a feature of existence. The universe expands because that is its nature, and perhaps we expand for the same reason. The moment of cosmic inflation is one of the most breathtaking chapters in the story of the universe. A moment so brief and so violent in its quietness that it reshaped everything that would ever exist. And yet it unfolded before atoms, before light, before even the concept of time as we understand it. Inflation was the era when space itself expanded faster than any speed we can imagine. Faster than light. Faster than the words we might try to use to explain it. Faster than imagination could hope to follow. But even in this staggering acceleration, nothing broke the laws of physics. Because it was not matter racing outward, but space unfolding beneath everything. As Alan Guth, the father of inflation theory, said, "Inflation is not objects moving through space. It is space making more of itself." And this single sentence carries the essence of the mystery. That the universe was not expanding into something. It was expanding into itself. When inflation began, the universe was smaller than a particle. And within a whisper of a moment, it became astronomical in size. This explosion of scale did not require matter to break the speed of light. Because matter was not moving through anything. The fabric of space-time was stretching, blossoming like a cosmic lotus opening in absolute darkness. Stephen Hawking once said, "Inflation explains why the universe is so smooth, so uniform, and so large." Before inflation, different regions of the universe could not communicate, could not share temperature or light. Yet today, the universe is astonishingly even, as though everything had once been close enough to touch before being pulled apart. Inflation is the only story that fits this miracle. But the beauty of inflation is not just in what it explains. It is in the poetry of what it implies. That space has no fixed shape, no fixed size, no fixed boundaries. That the universe can change, not through motion but through becoming. It teaches us that growth sometimes happens not gradually, but all at once, in a moment so brief that it barely qualifies as time. And this brings me to a personal reflection. When I think of inflation, I am reminded that change is not always slow, that breakthroughs in life can happen faster than we expect, that entire horizons can open in the blink of an eye. Inflation also shows us that silence is deceptive, that beneath what seems calm, reality may be rewriting itself. The early universe was quiet, yet in that quiet, space-time was racing outward at speeds beyond thought. This idea fills me with awe. The feeling that the universe has depths of creativity far beyond our senses. As cosmologist Max Tegmark said, inflation takes a tiny seed of space-time and makes it large enough to become everything. This image of a seed resonates with me deeply, because inflation is not just a physical process. It is a metaphor for possibility. That creation can begin from almost nothing, and yet become infinite. During inflation, quantum fluctuations, tiny, trembling distortions in the vacuum, were stretched across the universe, becoming the seeds of galaxies, stars, planets, life. Every spiral of a galaxy, every cluster of stars, every world that will ever form, emerged from the quantum whispers amplified during inflation. This truth makes the universe feel intimately connected, as if every breath we take originates from a vibration older than time. It also reveals a profound symmetry, that the largest structures come from the smallest fluctuations, that the cosmos is a tapestry woven from quantum dust. And in that symmetry is a lesson, that small things matter, that tiny beginnings can shape great destinies. Inflation also reveals something about freedom, the kind of freedom space-time has to rewrite its own laws. Einstein showed that space-time bends, but inflation showed that space-time can erupt, expand, transform with a creativity that transcends motion. Inflation reminds me that the universe is not limited by the rules we impose. It is limited only by the properties of space-time. And space-time, at its earliest moment, chose to grow. As Alan Guth famously said, "The universe is the ultimate free lunch." A sentence that sounds like humor, but carries a cosmic truth. Inflation allowed the universe to create vast energy from the vacuum itself, not violating physics, but following its deepest principles. This idea at first startled me, then humbled me, because it means that the universe did not expand into emptiness. Emptiness expanded into a universe. There was no outside, no container, no direction, just the pure act of unfolding. And this unfolding continues today in the accelerating universe expansion driven by dark energy, a faint echo of inflation's original breath. Inflation also carries a quiet, emotional truth, one that feels almost meditative. Growth does not always require force. Sometimes it requires letting go. During inflation, the universe released whatever constraints held it, allowing space-time to become what it needed to be. In our lives, we often cling, resisting change, fearing expansion. But inflation teaches that opening up, even briefly, can lead to unimaginable transformation. Today, we observe the cosmic microwave background, the afterglow of the early universe, gently rippled by the fingerprint of inflation. Like the faint memories of a childhood the universe almost forgot. Those ripples are not noise. They are the echoes of creation, the signature of a moment when space-time blossomed. And when I contemplate them, I feel a deep stillness, as though listening to a lullaby sung by the cosmos itself. Inflation is not just a scientific theory. It is a cosmic poem, a reminder that the universe was once smaller than a dream, then opened into all that is. And perhaps the greatest lesson inflation gives us is this: creation is not a single moment. It is a continual unfolding. The universe expands not out of force, but out of possibility. And we too expand, not through effort, but through openness. Inflation shows us that everything begins somewhere, even if that somewhere is impossibly small, impossibly brief. What matters is the unfolding that follows. The universe grew because it allowed itself to grow. And perhaps, so can we. The particle horizon is one of those concepts that seems simple at first glance. Yet the deeper you look into it, the more it transforms into something poetic, mysterious, almost spiritual in the way it reveals the limits of what we can ever hope to see. In cosmology, the particle horizon represents the farthest distance from which light has had time to reach us since the Big Bang, the true edge of the observable universe. Not an edge of existence, but an edge of perception. This distance is staggering. About 46.5 billion light-years in every direction. Far larger than the age of the universe in years. Because universe expansion has stretched space-time itself. As astrophysicist Ethan Siegel said, "The observable universe is not the universe. It is simply the part we can see." And this distinction is crucial, because the particle horizon is not a wall, not a boundary in space, but a boundary in time. We are not limited by how large the universe is, but by how fast light can travel across expanding space-time. Imagine the universe as a vast ocean, and our place in it as standing on a quiet shore. The particle horizon is the farthest wave whose ripple can still touch our feet. Beyond that, the ocean continues, but its waters will never reach us. To me, this realization has always carried a soft ache, a recognition that there are regions of the cosmos whose stories will remain forever unread. As Stephen Hawking once reflected, the universe has a horizon because light has not had time to reach us from everywhere. His words remind us that the universe is not old enough for its full story to have unfolded before our eyes. The particle horizon wraps around us like a cosmic shell, a limit set not by distance, but by time. The photons that reach our telescopes today began their journey billions of years ago, traveling across a universe that stretched under their feet, lengthening their path. And because expansion continues, new regions slip permanently beyond reach. What moves me most is the gentle irony of it all. That the more the universe expands, the smaller the fraction we can see. In a playful twist of nature, the cosmos reveals itself while hiding just as much. The particle horizon also explains why the observable universe is not a fixed size, but grows as time passes. Each moment, new photons arrive, carrying ancient information from regions that were once invisible. The horizon pushes outward, like the soft glow of dawn spreading across distant hills. Yet, even as we see more, the universe becomes more hidden, because distant galaxies slip away faster than their light can reach us. This dual motion expansion revealing while also concealing is one of the most haunting and beautiful features of cosmology. As physicist Brian Greene beautifully put it, we are surrounded by horizons, not because the universe is small, but because time is young. I often think about that sentence in moments of quiet. It reminds me that the universe is still growing into itself, still unfolding its possibilities, still shaping what will one day become visible. And perhaps we are doing the same. Understanding the particle horizon requires us to see light not as a beam, but as a history. Every photon is a memory of where the universe once was. Some come from star-forming galaxies, others from quasars, and the oldest come from the cosmic microwave background, the afterglow of the Big Bang. These photons traveled across a universe that changed beneath them, stretched beneath them, expanded beneath them. So when we say the particle horizon is 46.5 billion light-years, we do not mean the light traveled that far. We mean the universe grew that far while the light was traveling. This is why the horizon is so much larger than the universe's age would suggest. The fabric of space-time itself carried those photons farther and farther apart. When I contemplate this, I am struck by how small we are, not in a diminishing way, but in a humbling way. That we live in a universe whose visible region is only a tiny fraction of its total expanse. That what we can see is not all that exists. Yet, somehow, the part we can see is already overwhelmingly vast. This paradox teaches an emotional truth: that our perspective will always be limited. But limitation does not diminish wonder. In fact, limitation creates wonder. The existence of a horizon invites curiosity, creativity, imagination. Just as the horizon on Earth invites exploration. As Carl Sagan once said, somewhere, something incredible is waiting to be known. And behind the particle horizon, an unimaginable amount of something incredible waits. Cosmologists believe that beyond our horizon, the universe looks similar, following the same laws, the same patterns, the same cosmic web. Yet we cannot be certain, and perhaps that uncertainty is a gift. It leaves room for mystery, for the possibility that the universe is even stranger than we dare imagine. The particle horizon also teaches a personal lesson: that every life has horizons, limits to what we can see, to what we can know, to what we can understand at any moment. But as time passes, those horizons expand. We learn, we grow. New light reaches us. And just like the universe, we become larger in knowledge, in perspective, in possibility. There are regions of our future that remain invisible to us now, not because they do not exist, but because time has not yet allowed their light to arrive. And when that light finally reaches us, we will see our lives differently, just as the universe reveals itself differently with each new photon. So the particle horizon is not just a cosmological concept. It is a metaphor, a reminder that visibility is not completeness, that what we know is only a slice of what exists, and that patience allows the unseen to emerge. The universe teaches us that the unknown is not something to fear, but something to anticipate. Beyond our horizon lies not darkness, but possibility. And perhaps the greatest lesson of the particle horizon is this: we are not meant to see everything at once. We are meant to grow into the light as it arrives. The cosmic event horizon is one of the most haunting boundaries in modern cosmology. A border not built from matter or energy, but from time itself. A place where the expansion of space-time stretches so swiftly that even light, the fastest messenger the universe has ever known, cannot cross the widening gulf to reach us. Unlike the particle horizon, which marks the limit of what light has reached us in the past. The event horizon marks the limit of what light will ever reach us in the future. It is not a record of what has been, but a prophecy of what will never be seen. As astrophysicist Lawrence Krauss once said, "The most distant galaxies are not receding from us. The space between us is expanding faster than light can travel." And this acceleration creates a quiet and inevitable farewell. Because any galaxy drifting beyond this horizon, even if it shines forever, even if it burns with 10,000 suns, will send light that stretches away from us faster than it approaches. Its photons are carried backward by the tide of expansion, swallowed into a widening ocean of space-time. And over billions of years, those galaxies will fade, their light reddening, softening, dissolving into invisibility, not because they died, but because the universe carried them beyond our reach. There is a profound stillness in this idea, a recognition that the cosmos does not lose objects through destruction, but through distance. As space grows, visibility shrinks. Stephen Hawking once noted, "In an accelerating universe, most galaxies will eventually disappear from view." These words resonate with a cosmic melancholy, as if the sky itself is slowly dimming. Yet they also carry a strange beauty, a reminder that the universe is not static, but alive. Imagine standing on a quiet shore at dusk, watching distant ships vanish into a fog that thickens, not because of weather, but because the sea itself expands between you and them. You can see the analogy clearly. The universe is that sea, and the fog is the event horizon. Beyond that boundary, galaxies continue their existence, forming stars, collapsing into black holes, weaving cosmic stories we will never witness. This realization brings a quiet humility, because we understand that the observable universe is not the whole universe. It is only the shrinking island of sky whose light can still reach us. As expansion accelerates, this island grows smaller in a cosmic sense, and the event horizon grows larger. The future will reveal fewer galaxies, fewer clusters, fewer cosmic landmarks. As Nobel laureate Brian Schmidt said, "We are living in a special moment in cosmic history, when the universe is still visible." In the far future, a time long after humanity is gone, cosmologists believe the night sky may grow nearly empty, with only the galaxies gravitationally bound to us remaining. Even the cosmic microwave background will fade, stretched to wavelengths too long for detection. The universe will not grow dark because light has ceased, but because the horizon has carried all light beyond accessibility. To me, the event horizon teaches one of the most profound lessons in cosmology: that separation does not require motion, only expansion. And in our human lives, I find the same truth reflected. Sometimes people drift beyond the horizons of our understanding, not because of conflict, but because life expands, and their path stretches away from ours. The universe shows us that this is natural. That distance is not always loss. Sometimes it is simply geometry. The event horizon also reminds us that what we see is temporary, not because things vanish, but because light itself needs time. And as time stretches, so does the boundary between the visible and the invisible. As Carl Sagan famously said, we live in a universe of great mystery, much of it forever beyond our reach. But instead of despair, this fills me with wonder. Because the event horizon is not a barrier. It is a reminder that the universe is deeper than perception. We are small, but we are alive at the perfect moment to witness cosmic grandeur before it slips away. And in this fleeting window, we have the privilege to study, to observe, to marvel. The event horizon is a teacher, whispering that vision is temporary, understanding is temporary, even access to the universe is temporary. What remains permanent is the curiosity that drives us. The desire to understand a cosmos that does not bend to our timelines. The desire to love a universe that will eventually hide its face. The desire to learn even as the horizon grows. Maybe that is the final lesson the event horizon offers. That boundaries are not prisons. They are invitations. Invitations to wonder, to imagine, to accept that what we cannot see may still exist in beauty. The galaxies that disappear beyond the horizon do not cease. They simply continue their journey on a road we cannot follow. And so, the event horizon is not the edge of the universe, but the edge of our knowing. A quiet line written not in light, but in time. And like all horizons, it reminds us to look, to listen, to wonder, before the night grows quiet. The cosmological horizon is one of the universe's quietest paradoxes, a boundary that stretches and shrinks at the same time, revealing more of the cosmos even as it steals more of it away. And to understand this shifting horizon, we must gently return to the two great limits of visibility in an expanding universe: the particle horizon and the event horizon. The particle horizon tells us how far light has traveled since the Big Bang, and this horizon grows with every passing second, like the slow blooming of cosmic morning. Each moment, new photons arrive from regions that were once unseen, revealing deeper layers of the observable universe. The event horizon, however, tells us something far more somber. The limit beyond which light emitted today will never reach us in the future. And as the expansion driven by dark energy accelerates, this horizon becomes more dominant, more final, more like a curtain slowly closing across the cosmic stage. As astrophysicist Katie Mack succinctly said, "The future of the universe is an ever-shrinking field of view." This is the strange duality of the cosmological horizon. It expands backward into the past, while contracting forward into the future. The farther we look, the more we see into ancient time. Yet the more the future sky grows empty. The particle horizon increases as time grows. The event horizon decreases as acceleration grows. One horizon reveals, the other erases. And between these two shifting boundaries, the universe slowly isolates itself. As cosmologist Ethan Siegel put it, we will see more of the past but less of the future. This gentle truth leaves a strange ache in the heart, a sense that the cosmos itself is becoming more distant, more solitary, more withdrawn with age. And yet, there is beauty in the way the universe reveals itself before it hides itself. Think of the cosmological horizon as a breathing boundary, inhaling the ancient light of early galaxies, exhaling the disappearing glow of distant ones drifting beyond reach. This breathing happens because of universe expansion, a cosmic rhythm written into space-time. In the early universe, the particle horizon was small. Light had not traveled far. But the event horizon was vast. The universe's expansion slow enough that nearly everything could eventually become visible. Now, billions of years later, the roles reverse. The particle horizon is immense, 46.5 billion light-years in radius, a testament to how far ancient light has traveled. But the event horizon grows nearer, shrinking the region from which light may ever reach us again. It is this shifting dance that makes the cosmological horizon so mesmerizing. Like watching the shoreline of an ocean slowly retreat while the horizon above it stretches into infinity. Stephen Hawking once wrote, "The universe is not only expanding, it is isolating us." And though the sentence sounds lonely, it contains an almost meditative truth. For isolation is not destruction. It is simply the natural consequence of accelerated expansion. The galaxies that slip away beyond the event horizon do not vanish. They continue to live their cosmic lives, forming stars, merging, evolving. We simply lose the ability to witness their stories. The cosmos becomes a library with shelves drifting out of reach. I have often felt a quiet sadness contemplating this, imagining civilizations in far galaxies, perhaps asking the same questions we do, never knowing that the universe is slowly pulling us apart. But I have also found comfort in the symmetry of it, because while horizons shrink or expand, curiosity persists. The cosmological horizon also teaches us one of the most profound lessons in science. That knowledge grows not because the universe reveals everything, but because we learn to see within our limits. As Carl Sagan said, "We live on an island of understanding surrounded by a sea of mystery." The particle horizon marks the edge of that island. The event horizon marks the storm beyond. And between the two, we navigate, observe, learn. Perhaps the most important realization is that the universe is not static in what it allows us to see. It changes its terms with time. In youth, the cosmos was generous, offering more and more light as the particle horizon grew. But in old age, accelerated expansion will make it guarded, withdrawing its distant wonders. Billions of years in the future, the night sky will grow emptier. Most galaxies will fade into undetectable darkness, and the observable universe will shrink to a lonely handful of gravitationally bound companions. To me, this future is not tragic. It is poetic, reminding us that nothing in the universe is permanent, not even visibility. The cosmological horizon whispers a gentle truth, that everything we see is temporary. Not because it ceases to exist, but because light needs time, and time has boundaries. It reminds us to cherish the cosmic moment we inhabit, this brief era where the universe still reveals its distant galaxies, its background light, its ancient structure. Cosmologist Brian Greene expressed this sentiment beautifully. We live in a remarkable sliver of cosmic history, when the universe is knowable. This sentence returns to me often, especially when I gaze at deep-field images from Hubble or JWST. The thousands of galaxies captured in a single frame, each one a miracle of visibility. Someday, most of them will slip beyond the event horizon, permanently removed from the future's sky. And this gives their light a sacredness, a sense that we are witnessing the universe at its most generous. And so, the cosmological horizon teaches a final lesson, one that resonates far beyond astrophysics. That boundaries are not fixed. They evolve. They shift. They reshape our possibilities. And we, like the universe, must learn to grow within those shifting limits, to cherish what is visible, to accept what becomes invisible, and to trust that even in isolation, wonder remains. To ask where the universe is expanding is to ask a question shaped by human intuition rather than cosmic truth. For we imagine expansion the way we see a balloon inflating into the air around it, or a ripple spreading across the surface of a pond. But the universe is not a balloon, and space is not a ripple. There is no outside, no external canvas, no vast darkness waiting to be filled. The universe expands only into itself, rewriting its own geometry, stretching its own fabric, growing not outward but inward. As Stephen Hawking once said, the universe is not expanding into anything. It is simply getting bigger. This simple sentence carries a profound transformation in the way we must think about reality. Because when we ask, what is it expanding into, we are revealing the limits of our own imagination, not the limits of the cosmos. The universe has no edge, no wall, no boundary through which it pushes. It is all there is. And so its expansion is not a movement into something else, but a continuous unfolding of what it already is. Imagine a painting that grows larger without a frame, or a song extending its melody without needing more space to echo. The universe is that painting, that song. Expansion does not require room, because expansion creates room. This is why cosmologists say the universe expands everywhere at once, from every point, in every direction. There is no center because every point is a center. There is no edge because every point is nested within space-time's ongoing creation of itself. As physicist Sean Carroll put it, asking what the universe expands into is like asking what is north of the North Pole. The question dissolves not because it is foolish, but because the universe does not operate in the way our instincts expect. This realization is both humbling and liberating, for it teaches us that reality is not bound by analogy, that the deepest truths are those we must grow into. When I first understood this, I felt a shift inside, a widening, not unlike the expansion it described. I realized that so many of our questions about the universe are shaped by the world we inhabit. a world of inside and outside, of containers and contents, of boundaries and directions. But the cosmos has no such constraints. Space expands without needing a place to grow into, just as time moves forward without needing a future pre-built for it to enter. The expansion of the universe is simply the evolution of space-time, the ongoing transformation of what exists. And this is not a peripheral detail of cosmology. It is the foundation of our understanding of universe expansion. Inflation, dark energy, the particle horizon, the event horizon. All of these ideas become clear only when we accept that space expands by creating more space, not by moving into a void. Alan Guth once reflected, "Space does not need room to expand into two. Expansion is the room." This statement is almost poetic, yet it captures the heart of the matter. Expansion is not a destination, but a process. Not a direction, but a transformation. The universe expands into its own possibility, its own potential. It is the pure act of becoming. Some find this unsettling. The idea of a universe with no outside, no boundary, nothing to push against. But to me, there is comfort in it. The universe is whole, self-contained, complete in its incompleteness. It grows the way a thought expands in the mind, or the way awareness deepens in meditation. Quietly, inwardly, infinitely. And perhaps this is where the deepest personal lesson emerges. That growth in our own lives does not require an outside, an escape, a new world to enter. Sometimes growth comes from expanding within ourselves, from allowing new space to open in the mind, new compassion to form in the heart, new understanding to unfold within our perception. The universe expands without reference to anything beyond it, and we too can expand without reference to comparison. This cosmic truth offers a profound, gentle wisdom. That expansion is not outward striving, but inward unfolding. And so when we ask what is the universe expanding into, the universe answers with silence. Not because it refuses to speak, but because the question itself contains its own misunderstanding. The universe expands because that is its nature. And it expands not into something, but into itself. As Carl Sagan beautifully said, we are a way for the universe to know itself. And perhaps expansion is simply the universe increasing the space in which that knowing can occur. As I reflect on this, I am filled with a sense of calm, as though listening to a slow cosmic breath. The universe inhale, creating space. Exhale, unfolding time. Growth without movement. Evolution without direction. Pure becoming. And the final truth is this: the universe is not expanding towards something. It is expanding into the widening possibility of its own existence. There is no edge, no outside, no boundary. Only the infinite act of unfolding. And perhaps, in our own quiet moments, we can feel that same unfolding within ourselves. In the end, the great mystery of the expanding universe brings us back to a simple and humbling truth. The cosmos is not racing toward an edge, nor is it unfolding into some vast external darkness. It is growing within itself, deepening its own structure, stretching its own fabric, and continuously reshaping the possibility of existence. Every horizon we've explored, the particle horizon, the event horizon, the cosmological horizon, reminds us that the universe is a place defined not by boundaries, but by evolution. It is a living geometry, a silent breath that has lasted for nearly 14 billion years, and within that breath, we have found our place. We are tiny observers in a vast and restless cosmos, yet somehow we are here at the perfect moment, a moment when the night sky is still rich with galaxies, when ancient light still reaches us across unimaginable distances, when the universe still reveals its story before allowing it to fade. That is a rare gift in cosmic history. And perhaps that is the final lesson: to cherish what we can see, to honor what we cannot, and to remain curious even as the horizons shift. Thank you for joining me on this long journey through space, time, and the quiet beauty of the expanding universe. Your presence, your attention, and your wonder make these explorations meaningful. If this journey has stirred something in you, a question, a sense of awe, a moment of quiet reflection, I invite you to stay with the channel, to like, to subscribe, and to continue walking with me through the mysteries that lie ahead. Because the universe is still opening, still unfolding, and together, we'll follow where it leads.